Here you can see we've got fractions under the radical sign that will be simplifying. We're using the quotient rule now to help us break apart the single fraction that's under the radical so that we can write it as two separate radicals. So the square root of this fraction is the same as writing the fraction separately. In the numerator, we'll have the square root of 36a to the 10th, and our denominator will also be a square root, and that means 49b to the 6th is under the radical. The reason why we're able to separate this with the quotient rule is because both 36 and 49 are recognizable as perfect square numbers. So the square root of 36 you may know as 6 because that comes from 6 times 6. So we know at least 6 will clear that radical in the numerator. With 49, I know that 7 times 7 makes 49. So 7 will clear the denominator. Now working back with our variable bases, a to the 10. 10 can be divided by our index of 2. I know that it's 2 because this is a square root problem. So 10 divided by 2 equals 5 remainder 0. So the base of a will clear the radical with an exponent of 5, and no base of a will remain because the remainder is 0. I can use that same technique in the denominator with our base of b. 6 will be divided by the index of 2, and that leaves 3 remainder 0. So with our base of b, the exponent of 3 will clear, and there are no bases of b remaining under the radical. So my final answer is 6a to the 5th divided by 7b cubed. We can apply that quotient rule now to this cube root example. Just be careful that you're using cubes now instead of perfect squares. So we want to break 27 down, and it's okay if you want to use your factor ladders here. Just divide by a prime number. 27 is divisible by 3, leaving 9. 9 is divisible by 3, leaving 3. 3 is divisible by 3, leaving 1. So you can see that the base of 3 repeats 3 times, meaning it's a perfect cube. So with our numerator, we had the cube root of 27x to the 6th divided by cube root of 125y to the 12th. We just found out that 27 is a perfect cube, so our numerical coefficient of 3 will clear. Taking 6, dividing by index now of 3 is exactly 2 with no remainder. So that base of x will clear with an exponent of 2. For the denominator, I'm starting with 125, and I'm going to see if I can divide that by a prime number. Since it ends with 5, I should be able to divide by 5. 5 goes into 12 2 times, 2 left over. 5 goes into 25 5 times. I can divide 25 by 5, that leaves 5. And I can divide 5 by 5, leaving 1. So I can see that 125 is a perfect cube, and the common factor there would be 5. So 5 will clear. 12 divided by 3 is exactly 4. So the base of y will clear the radical with an exponent of 4. My final answer is 3x squared divided by 5y to the 4th. So the quotient rule is very useful when you have fractions.